Okay, so we have to find the limit as theta approaches to 0 from the positive side. We have to find the limit of s over d. Now s is the arc length. Okay, so recall that s, the arc length, is the radius times by the angle inside, which in radians. Also, we can express d in terms of as a function of r and theta, right? If you use the cosine law, so we get d is equal to r squared plus r squared minus, right, 2 times the both opposite sides times by cosine of theta. So let me actually clean that up a bit. You get 2r squared minus 2r squared cosine of theta. Okay, so you can factor out 2r squared. So you can square root both sides, you get root 2r. Okay, let me actually put r at the front. Root 2, 1 minus cosine of theta. Okay, so that's what we get for d. Okay, so now let's divide s and d in the expression of with r and theta. Okay, so note that the r disappears. Okay, so let's find the limit of that expression. So we have theta all over. Okay. Now with trig limits, we always want sine. Okay. So to get sine from 1 minus cosine of theta, we need to multiply by conjugate pair, but it has a square root. So let's multiply by the square root of. Let's do exactly the same. 2. Okay. 1 plus cosine of theta. Okay, so I chose that because it's going to make the bottom relatively much simpler than what we originally had. So we get 2 times 2, which is 4. Square root of 4 is 2. Under the square root, we have 1 minus cosine of theta times by this, which is going to become that. Okay, on the numerator, we have okay, so note that that's going to turn into sine. Right, so we get sine square theta. It's going to turn into just sine, right? Because if you root a square, you just get the function under it. Okay, so now what we have is that this theta over sine of theta is going to approach 1. Okay, that's going to approach 1 when you take the limit. So we have 1, 2, 1 plus 1, cosine of 0 is 1, all over 2. That's 2 times 2 over 2. That's 2 over 2, so the whole limit is 1.